Hello everyone, welcome to Knowledge Optimizer. I am Rajat and today's topic would be relational database. So in this we are basically going to cover PostgreSQL only. So what is relational database? So you might have heard of this definition before only. This is a bookish definition only. It's a type of database that organizes row and column. But our real question is why this data is stored in this way. So that we are going to solve. So if you see like our table is nothing just a combination of tuple and then tuple is nothing just a row. Then these tuple are basically map attributes to some atomic value. These atomic value in our case is this rex, dog, big. And then what are the headers? Basically, what are the attributes that are defined in the headers? And how we are defining headers is basically while creating a table, we only give the column name. This is called column name along with the data type, like how what kind of data that column can store. So there are various kind of database. I think you might have heard of or might have used MySQL. Then this is SQLite. So today we are going to cover PostgreSQL. So you can download. I won't cover like how to download everything. You can download it from this official from official website only. So content of today would be working with tables. Like we are going to understand what are tables, how data is stored in those tables, then basic CRUD operations, then relation joins, and last but not the least that we are going to understand is indexing, like what kind of indexing Postgres support and how it is beneficial for us. Hoping like you already have downloaded Postgres. Now let's get started with it. So I'll be using Docker for starting the Postgres in my in this basically series. And so I have already installed through a Docker image. I'll just open it in terminal. I can also open it in external terminal. So what it does is basically run this container. So how Docker works and everything else in detail, I can start a series on that. You can just let me know in the comment section. So we have this terminal open for this container. So I'll just connect with localhost user. So I have created a new user, this Postgres. I'll so if I want to list all the databases, then there's this small command, like instead in MySQL I think it is show databases. So here just backslash and then L. So it will give me all the databases I currently have. So this is if you okay, like how this is created, I'll just explain it to you also. Before that we'll show like what is this template 0 and template 1. We have never created this database. Even if you list all post installing, just list all the databases, then also it will going to show you this. So the real question is what is this template 0 and template 1. So template 0 is, so these are basically from the name you can see like these are just a template to create a databases. So whenever you create a new database, you can just provide create. Suppose I am creating a new database knowledge optimizer. Then I can just provide like from which template create my database. So what is the difference between two? This one is immutable, so you cannot basically make change in this template. Whereas in this you can basically add extension. Like if you want to add HStore, basically key value support, basically data type you want to have in your table, then some JSON B if you want to enable, and those things, all those extension you can add in basically this template. This can be modified while this cannot be. That's the difference. So default one is template. Whenever you just do this create database knowledge optimizer, then if you don't provide any template, it basically take run this command, take default template as template one only. So create a database created. So also there is one more tool I'm going to use for this series, that is dbeaver. So there are other tools also, pgadmin and everything you can use. So I'm going to use dbeaver for my use case. So I'll just start. So I already created this basically this folder. It connects to local host. So if you'll see edit connection, if I'll just go to edit connection, I hadn't provided any database, then username is used if not is specified. So basically it has created this default database for me, Postgres, by itself. So when I was showing you this, so if you don't provide any when connected to any host to any connection, when you are making any connection through dbeaver, if you don't provide any this database name, basically it create a database with this username. So that's how it was created. So I'll just further open. There are going to be two databases, one which we have just created while other one unconnected. So if I'll just go to schemas table, they won't exist any table. Okay. So I'll just open a SQL editor, SQL console. Hmm. So this is going to be my console. Let's create a table here. Create a table countries. Then we are going to provide some country code care, like this is basically the data type I want to give. So this is country code 3. So I'll just give you like primary key, then this country name, text, unique key. So they are basically two fields. One is primary key, one is unique key. I've created a table with this. Okay, I'll just execute it. Then it has created a new table. If I'll just refresh it, you are able to see this table. Okay. So if you'll see, just see here, like I have used along with the data type I've defined here, like it is going to be text or char, where char. So along with them, I have provided two kind of keywords here, primary key and unique key. So what is the primary key and unique? The primary key is nothing, just an identifier for a particular table. So it has to be, first of all, there are some constraints, like it cannot be a null. There could only be one primary key. It has to be unique, basically. So basically, it created an index to retrieve values out of that tuple or row, you can say. Sorry, table. So it is a unique identifier. So what is unique key? So basically, it also ensures like the uniqueness of the column. Again, this can be column or combination of column. It can be composite of multiple columns. It can be same for both. I think some of the people are confused. Like primary key can be generated with just a single column. No, it can be composite also. You can create a primary key over two columns basically. So again, this is also contains a unique values only for a particular column, but the only thing here, it can contain null values. Okay, there can be chances like if it doesn't exist, then also it is fine. Then multiple unique key we can define. There could be just a single primary key where there could have been like multiple unique key or whatever. So I'll just show you like how to create a unique key, how to create a unique key over a composite key and everything. So there's this main differences between them, and yeah. So so we have created a table, and you have seen like the table is one table is created for that particular. So let's insert some data. So let's insert into. So what we have done is basically insert into countries, country code, country name. We have provided there are two columns. We provide what kind of values. So if we'll just format for you. So yeah. So these are 7 8 countries we are inserting. So I'll just insert this. So updated those 8. So there were basically 8 countries we have inserted. So this is the one. So if you want to see when the property is basically going to show me like the data type and not null value. So for in case of primary key, basically it will default take it as a not null. Else you have to separately provide, like while creating unique text not null. kind of this you have to provide. So that wasn't but in case of primary key, it basically take the default, it has not null, basically default constraint for it. So now we have inserted some data and you can see clearly see. So let's try inserting basically the existing value once again. So suppose United Kingdom we have already inserted. So let's see like what this unique constraint do. Okay, what this unique primary key does for us. Okay, so I'm just trying to insert this United Kingdom again in our table. So if you'll see like duplicate key violates unique constraint. So if you'll see, you can see this error. Now suppose I'll just change this to, now you can see like this is a separate key we have created, but again the unique constraint is there. This failed due to primary key. Now let's see whether it will fail for unique key also. Okay, now I've just changed the basically country code, since country code was the primary key. Let's see. Yeah, it has failed again. So a duplicate key, country name, United Kingdom. So if I just do this, then also it will fail. Oh, basically we haven't inserted. So that was GB we haven't inserted for this. Okay, okay, my bad. So if I had done something like this, so United Kingdom one, so it would have failed with the country code. Okay. So this is basically so far we have created a database. We have inserted some values. So how we are going to basically select from this table now. So we have seen like how constraint work. Let now try selecting some value. So there's this like select star from country C, basically give me this list. So you all should be wondering like how this these queries which we are running are internally working. So there's nothing, just a you can say little math behind it. Okay, I can just show you like how this is working. So I think we have already discussed what is tables, 2D matrix, rows, and all those things. So how does query work? It is nothing, just as if you are familiar with the set theory, you might have read about relational algebra. So how does it work? Selection. First of all, there is a selection. So if you'll just see this, select x dot name from people where this is some condition. So what we have to select is basically what condition. So that comes under selection, where this age is something something. Okay, then what is the projection, like what we are kind of returning. Then this is considered as a part of basically select statement. Then if you want to make a join, so if you in the relation algebra, so basically you used to take that Cartesian product between two matrices. Okay, over something xx. So this is basically done by join. So we are going to see like how it basically does that. Okay, that too. So if you'll see, you can like simply see like it's nothing, how the query is working, nothing, just the algebra we are running here. Okay, so different part of the query would be match of the basically like what operator we have to apply. So that's how basically query works. Now we were on the select statement. So we can apply some condition also here, like where c dot something country code equals to, we applied UK earlier. No, yeah, it would be single quote, my bad. So you can say like it is going to give me this, if I just for this, then be going to it's not country code, it's country name. It will basically give me US. If I just want to sorry UK. I, If I just want the country code in the projection, basically I could just do country code, then it will give me this basically US or something. So I can, if I want to fetch multiple column, then country name, c dot country name I can provide in the projection, basically in the select statement. So star, what star does is basically project all the attributes of that table. So you can change it, you can play around it, like how to project, what to project, and everything. Now let's jump into like basically, and let's add another table. So hmm, you want to see like how join works and everything. So let's create another table. So we are going to create a cities table. Okay, create table cities. Then basically we can provide different name like text. So I was telling you like how we can provide whether it has to be not null value or not. So here's how we can provide. Then postal code, city has postal code. Snake case is the usual format which we use in Postgres. So in maximum of the databases that would be snake case only we use. So where char, yeah, it is also same as char. So check. Now there are some kind of condition also we can apply whenever we are creating some basically whenever we are defining table. So we can add later also with alter command and everything, we can basically add condition also. So here we are going to add some condition like on the postal code it cannot be empty. Okay, this is the condition we have added. So then we have country code. Country code is basically why we are defining country code here. Nothing, just L for reference. So we are going to understand like what is this reference basically in a bit. Reference, what were reference countries, and this is our another table. This was primary key. I can define primary key separately. So I told you earlier like many of the people think like primary key can only be a single column. So we are going to create a primary key from this composite basically from this combination of columns, attributes you can say. So I'm just create country code plus postal code. So from these two basically I have created this. This is nothing, just a compound key. Okay. uh, so we are going to create a primary key out of these two. So by the way, if you are confused, this is not symbol in Postgres. Okay, yes, might have seen this. So postal code cannot be empty. So if I just create it, country name, so, oh, my bad, it was a typo. Hmm. So it basically have created a cities table now. Okay, if you will again refresh it, you will going to see two tables now. One is countries. So yeah, so let's insert some data in the cities table. Okay, let's try inserting some data in the cities table. So first of all, what is this reference is doing? So I think from the name only you can see like we have created a column country code reference to the countries. Now it will basically going to search in the countries like for this particular column, and it is going to use it as a foreign key. So it basically references to countries table. So in the countries table I am going to show country code is the primary key of that table. So we are going to further make a join, then you will clearly understand like how does it that work. So before that I'll try to insert a data in this cities table. So I have create for Toronto city, city basically I'm inserting a data. So I have provided the country as basically it's a Canada, it's in Canada. So but I haven't inserted any data in this. So will it fail or not? Let's see. So if I just run it now, you can see like I got this error. Insert or update on table violates foreign key constraint. This cause this key is not present. So what it is doing now, since I have provided reference to other table, so it will first going to search in this table like whether this key exists or not, this basically attribute exists or not in other table, then only basically it is going to insert. So you got the basic gist, like how it is doing that. So instead of Toronto, let's insert client at US. So now see, it is successfully insert failed cause this city never exists. No, sorry, this country never exists in our country's table. Whereas this past cause this for, this country exists in our table, in the previous table. So this is what this foreign key constraint do. Okay. Now basically, now since we have inserted the data, we have left with the, I think we have created a database, then we have inserted some value, then we have projected create, read, and update is remaining now. Let's update some data. Okay. Now we had this port len, basically created a name. So from that particular column I'm going to update basically the postal code for particular cities. So it is updated. Earlier it might have been, I'll just refresh the content, you can see like 97206. If I just change it to 01, so if I'll just refresh it, it is updated to 01. And also from here it is basically going to show like you can directly go to this table also, like this is the feature of dbeaver on the basically it show like which it is reference to and everything. So here you can see like in the panel you can see like going hmm. Now so you have created this, I think delete is left. Delete is nothing, you just have to provide some kind of delete from some table, like from countries table we can read one country. Delete from country you can like this t is a fake country, I can just, yeah, country equals to t, there should be again single quoted. So if I just refresh this table, then t cannot end. So basic CRUD we have covered so far. Now let's jump into like joins. Like how, what is join? First of all, what is join? That's the question. So again, so this is the basic CRUD we have covered so far. Now let's jump into like what are, now we are going to see like what are joins, what kind of joins you can have, and all those things in SQL. Okay. So suppose like I have to basically fetch, I have to make a join on. So we have provided the reference to the countries and the cities table. So now let's create a join over it. So if we'll see what I am doing here, selecting from cities inner join countries. So I'm just providing a inner join. So here I have, so far we have covered basic CRUD operations like insert, create, insert, delete, and then update. So now let's jump into joins. Okay. And what kind of joins we have available, we are going to cover later in this in this video. So so we have already provided a reference of countries table in the cities table. So I'll just select star from cities, inner join countries, COU CI, sorry, CNCI on. Basically now I provide like make an inner join on what is on, my on ci dot basically on which column, country code equals to cn dot country code, where so okay, this is all. So first of all, it is going to now see like how it is basically making a join. When I was trying to explain you what is Cartesian product, basically if you are aware in the relational algebra. So first of all, it has taken basically this country, sorry, this city, basically all the columns of the city. Then it has basically attached all the columns of the country. So if you remember like how we do the Cartesian product between two matrices, this is how this is making a this also. So but if I just want to print basically the cities table information while making a join, so it's just like this. Okay, so to make you understand better, I'll just insert another data, New York, not New York, London, some random pin code, UK. Okay, now if I just print it, just make a star and going to print two cities for me. So if I just want to get like the second one only, so I can just add a condition here where c n dot country code equals to, just do it here, and c n dot country code equals to what, US, UK. So I just want to print all the cities of London, basically, sorry, all the cities of UK, United Kingdom. Okay, now it will basically give me London here. Okay, if I just want to get the series data, I'm not interested in the country data, I'll just do this. If I want to print a specific column, ci dot basically name, I just want to fetch the name of the particular city, so it will going to provide me this. So if I just insert one more city, okay, here, hmm, okay, add one more cities, it will going to give me two cities. So I just want to add another constraint here on city table now, like postal code is equals to something something like this. So it will give me just Paris. Okay, so you can do like many other things also. So I have written, if you have noticed, I have written here inner join. So what if I just remove it, then also it is going to give me Paris only. But as soon as I am going to, so yeah, before jumping into this, so you can see like clearly it gives me both of this inner join and join give me same result. So basically if you don't provide like what kind of join is there, then also in case of, in this case like the default join it takes as inner join only. So consider the case now. Okay, it won't be possible actually. So outer join can't be possible as we already have added a constraint on over that. Like it has to be a over primary key we have added the constraint, and since we know that primary cannot be null, then we cannot make an outer join. I'll create a separate table, basically from this we can understand like how to make an outer join. Before that I want to show you like what kind of joins are possible. So this is an image which I fetched from Google, like I think the creator name is also there. So what kind of joins, like you can see this one we just have ran the query, no? This is the join for which we have ran. So there could be a part of a where which is not common, okay, and there could be part of b which is not common, but it will, in case of inversion it will also consider the part in which is common. Okay, similarly then we have this right join, we we have this right join without common. So basically we have just added a condition like a dot key is null. Similarly, these are kind of the main join are basically of four kind, that is inner, outer, right, left. But then there are for particular constraint we can even fetch this basically through this Venn diagram. So we'll try to explain like what kind of query is going to basically give me what kind of set basically. So so now let's create another table so to better understand like this join. Okay, so I've just created a table in venues now, and I provide like venue ID as serial. So what does serial means basically? Now you are confused. So if you, in MySQL, you might have heard of auto increment or any of that data type we provide to some primary key. So it basically auto increment the value. So it works in Postgres. It is serial. So basically it will create primary key, obviously in data type, and basically it is going to auto increment the value for this particular primary key. Then name, varchar, street address types, I think you already know. Then type tag, then there we have provided basically the check. We have already earlier also we have applied some kind of check on postal code, not null, not empty. So here we also have provided the default values. Okay, so what is the actual use case of default value? Basically whenever we provide any not null column, right, then basically someone forget to add the value for that particular column, then basically we usually add that default value also. In those cases it is mainly used. So if you have added not null constraint also on that column, so you can provide it here also. We have provided like something of that kind, like if someone forget to add the type, then it will make in maximum the query it will fill. So that's why we have added like the default would be public, and the check we have provided public private. Postal code, country code, then we have provided kind of foreign key, and now it is the composite key. The composite key we have provided the foreign key. Then it reference to the cities table, and matchful. Matchful is just matching this. Okay. Now I'll just if you'll just see here. Oh, I haven't run the query yet. So there's this venues table which has been created. Okay. Now I'll just insert some data to it. Okay. If I use some random data like alien ballroom 900, so I'll say 97. Yeah. Okay. Now let's create. So first of all, okay. So if you'll see venue ID is 1, it has started with 1. Okay, name, then public, default. So I haven't even added public or anything. So default it has added it to public. Then also it has started venue ID with 1. So I'll just insert one more data. Okay. Do donut here for this particular same. Just insert it. Voila. So if you'll see, there are two venue IDs. Now venue ID is updated to 2, then this name public again it is inserted. So it is basically auto increment. If I delete some of the edit and also post that, it will auto increment the value. Okay. Now so yeah, we had understand like how inner join works. Now let's move to outer join. I think I have already show you from Venn diagram like how you're going to basically get the values. Okay, these all are kind of outer join only, except this inner join. This is left, right. This is outer join. Okay, this is also part of outer join. I'll just show you like how it is working. Okay, so let's create an one more table. Understand it better. Okay, now I created this event table. I think the data type are pretty easy to understand here. So I have inserted some data to it and some more. Here I am not going to provide the venue ID. Okay, so here I provided the venue ID key also, references whatever it is referencing. Here let's not add any venue ID. Oh, okay. Hmm. So if I just refresh this, then see the event table data. So they are one with referencing. So if I just create, you can also see from on which table it is referencing, and then one is null. Okay. So let's make and join. Mm. So if I just make a normal join, okay. Now what is going to provide me? I think you are already aware. Just one tuple it is going to provide you fight club, and then the venue name. Okay. Now if I want to get like all the attributes basically of this event table, I want all the attributes of event table, whether it basically exists in the venue, whether venue exists or not for that particular. Okay. So I'll just make this as this. Okay. Venue id equals to, I have provided the left join now. So the left, even if in case of null values, then also the left would be completely shown to me. Okay. Okay, it has basically, okay, added a join on it. Okay, it has provided the venue name, but here it has populated the null values, the left table. Like I want all the data of left table, whether there is a join for this right table or not. So this is how this. So if I have written this outer join also, so now it consider for both, since here not null values of this left table are allowed. Okay, while making a join. Now with the outer join and with right join, basically not null values of right table are allowed. Okay. Now with outer join, not null value of both the tables are allowed. Okay, you can read more about this join. I think this is pretty straightforward. So far we are seeing joins and everything. Now let's move to indexes. Okay. Now, what are indexes and why we actually need indexes? So, if you are seeing like so suppose like consider this event table only. So, if I have just for search for Christmas days, okay. Now, how much search it is going to do? First of all, it is going to search sequentially, okay. Till first of all, okay, for this event ID, whether the title is this Christmas day or not. No, then okay, it is Christmas day. Then April Fool, in the April Fool's Day, okay, it is not Christmas day. Everything it basically iterate over the whole table, and it will going to give me that result. Then further, even after matching here, it will also do the character match. Okay. Now you can see how tedious this task is, how time consuming it is going to be. Okay, so for those purposes, like for such purposes only, we have introduced this indexes for faster lookup only. Okay. Now let's, okay, suppose I want to basically get the events where title equals to Christmas days. Okay. Okay, it has given me this data. Now, explain analyze is a kind of keyword you can say, through which you can basically analyze any query. Okay, I want to see like the execution time. So they are different like the how much scan it has done, how much loops and everything it is there. Okay. Then this execution time you can see. Okay, this is 0.041. Now let's create an index on this event title. Now you won't be able to see huge difference between it. Okay, the reason for that is simple, because the data is very less, just the 3 rows. Now let's create an index using hash. I think you might be aware like how to create a hash. You can see hash function to understand it better. So basically we create a hash value for a particular whatever it could be string or anything. So we create a hash for that for particular column on particular attribute, and then basically we create an index over that hash could be like the size we can define, like for how much size we want to create a hash. So I have created an index, okay, event title using some hash. Okay. Now let's see the execution time. You can see it has decreased to 0.038 millisecond. See, so that's the difference between those. So if has there been huge data inside this event table, you could have seen a huge difference between this execution time. It is decreased by 3x times. Okay, sometimes. Okay. So yeah, so what are, so can we create, so is this Postgres use hash and default? No, we have created a hash. Now the next question came. So if you have seen, like, even the Postgres supports this greater than less than queries also. With this hash, I don't think you can support that, right? Hash just created a hash value for particular attribute, then is stored it. Now we are going to search for that hash. Whenever we are going to search for that, from that hash we are going to get the key which we have to get, and then basically the mapping is going to happen, like which particular row we have to fetch. Okay. Now the real question is how to support this greater than less than query. Okay, like in the case of venue ID greater than this something value, venue ID less than something value. There comes a B tree for R. So the default index which we use whenever you create any index, whenever you create a primary key, the default index which being created over it, that is B tree. Through B tree data structure we are using. Okay. Now, okay, hash I just explained to through a figure like select star. Now, event hash is created. This is basically for particular pointing to a particular row. So this is basically the default index, the main thing, main crux of this Postgres indexes. Okay. Now you can see, like, we have this query, something greater than or equals to. Now we have a huge chunk. Okay, huge range we have defined. Okay, already, like 1 to something max number. Now we have created, further divided them into chunks. Okay, so first of all we are going to validate, like, in which range this search we are making, in which range it is valid. Now further there could be like different layer would be there. Okay, suppose here in this case this is some I think big number greater than this, it will going to go this basically in this chunk. Now we know, like, what are the valid values for that. Now we got those keys basically through this b tree index. We got those keys, we just have to fetch now on the primary key only. We just have to fetch. Okay, just get the whole data on those primary key only we are going to get. Okay, as simple as that. Now the question is, so won't it be too hard to create this tree? Yes, it would be. What is the time complexity for read? Since this B tree is usually created for queries like which is read heavy, for databases which is read heavy, then only we are using B tree. If it is write heavy, then there is no point of using B tree. Okay, why? So B tree, first of all, the complexity or the time complexity for fetching is log n. You can see, like, first of all we are defining chunks, then further we are breaking them into many chunks. So this is basically log n. Okay. Now the question is, B tree basically maintain itself whenever you are inserting some value, like where it has to insert the data. That is during the write operation. First of all, it basically insert the data. Now it has to make a balance to keep the complexity, like read complexity, to basically on. Oh, sorry, log n. That's why basically whenever you make an insert operation, it basically auto balance itself. Now that's why it's basically write heavy. If you have seen, write operation is heavy in the relational database or in basically the Postgres. If you have seen this statement, that's the reason for that. So I think, yeah, there's more around B trees. Now, like how basically we can so similarly to hash, we can also define B trees like this only. So if I want to create a basically index on the start time, then I can create, like, using B tree I can provide start time. It will basically create a index on this start time using B tree. Like here we have created using hash. Are there any other type of, if you haven't provided, I have written something like this, then also it will work the same. The default index which it takes is B tree only. Okay. Now, now, so the next question was, are there any other type of indexes also which Postgres support? Yes, there are. So they are these other indices. This GIN, basically general inverted index. This is used for full text query. Then this gist, then speeches, then block range indexes. So these are other different type of indexes which this Postgres supports. Let me know if you want to know more. If you want, let me know if you want to know more about these indexes, like how it works, and the internal working, and how it optimizes our queries, and where we have to use which kind of indexes. So you can just comment down in the comment section. I'll create a video about it. So that's more around what we have covered in this, okay, and we are going to cover. So that's all from this video. So in the next video we are going to talk more about like advanced queries and advanced topics, okay. So thank you everyone, and please subscribe and share.